Okay? The southwest corner. Less than everything in the northeast corner. What we did, instead of sorting the array, 2 rounds, each round is a quarter. Over 2, 10% is less than it, 30% is bigger than it, so the most unbalanced 30 to 70, the biggest what says. It could be better, but it's never going to be worse than 70%. So questions. That was the first thing I owed you. The first thing I owed you was a proof of this lemma, which is what justified filling in the input size of the second recursive call to be 710. But I still owe you proof the rest. Thank you.
Back to what I said earlier.
So if you wanted to preserve it, I mean, so that and so, oh yeah, so one thing I should say is, probably this is clear to you, but we have been a little bit sloppy. Okay, and I tried, someone want to kind of nitpick and sort of point out somewhere where I stole. Yeah. Remember one. It's not 7/10 n, it's 7/10 n minus 5 or something like that. As you would. makes the proof a little more known exactly what handout, and I'm not going to spend the lecture time doing it. So it's all kosher, but so you know, this is slightly sloppy. Okay, for reasons of that form. Okay, with that said, just to focus on the main ideas, this slightly sloppy recurrence, this is the one I'm going to analyze formally. Okay, so I will give you a bona fide proof that this evaluates to linear time. The same methodology works for the really precise recurrence. Yeah.
When you say there were recursion on these 70%, can you say?
At most 70%. Yeah.
Where can you talk about?
Well, let's see. So the question is, could we optimize? Factors. Always assume the worst type for that. Different sizes, that's right. Yep. Yeah, because if you go back to the, like I said right at the top of the board, assume that all the subproblems have the cause, and each is on the same. Now that's the one I told you Tuesday accomplishes that. Handle different size subproblems. An alternative thing to do would be to look one of those up in the literature and apply it here. I wanted to show you a different on this recurrence. Okay. All right, so so before our final kind of proof of the lecture, maybe just a quick comment. So I really hope that by the end of this class, and algorithm. It's not that recent an algorithm. It's even before my time, so it's certainly before your time. It's from '73. So the authors are Manuel Blum. He's a professor at Carnegie Mellon. Bob Floyd. He spent most of his career at Stanford. He died about 10 years ago. Ron Pratt. He's down the hall from me. He's professor emeritus here. Ron Rivest, who's a professor at MIT, and Bob Tarjan, who's a professor at Princeton. So I didn't want to guess. So how many words there are among okay, so plus one came to this. So Manuel Blum won it in '95 for lots of contributions to theory, program checking, and other things. Floyd's name will come up again in algorithms. He did a lot of fundamental work in algorithms. So let's see, Bob Tarjan, he's along the top right. What we do in worst case algorithm. Some more. have to be content with being sort of, having lots of huge results like all right. So it's okay if this one is not something you would have come up with by yourself. Maybe by yourself with 4 good.